Hello and welcome everyone to the Access for IT Teams video series. My name is Bastert and I'm Global Product Manager at Access for Access OS, our Linux-based operating system that powers most of Access network products. And today with me I have Ronald from HPE Aruba Networking.
Hi, Andre, and hi, everyone. My name is Ron Kent, and I manage security partnerships for Hewlett-Packard Enterprise. I'm based in the United States and have worked in cybersecurity for the last 18 years. And I'm very happy to be here today with Andre to talk about our partnership and what we've been doing together to make things easier and more secure for our joint customers.
So in this video series, we will showcase practical integration guidelines and their technologies that are used by Access network products to integrate securely into zero trust networks. But we cannot do this job alone. That's why we work closely with partners such as HPE Aruba Networking to create these solutions. And with Ron with us today, I hope we can work out the details of our joint integration and outline the benefits that these bring to our customers. So Ron, supporting Aruba's customers in securing networks every day, what type of challenges do you see in the market, specifically looking at all sorts of IoT devices running on your network fabric?
Well, a lot of our customers are concerned about unauthorized access of network traffic. Besides the potential privacy concerns around accessing the data that's moving through the network, there's actually a lot of information moving around that gives potential attackers important clues about the structure, topology, addressing, and other parameters about the network. These are things like DHCP, NTP, ARP, DNS, and other low-level network functions. Even when a device or application has the forethought to encrypt the traffic and telemetry it creates, it still leaves a potential trail of unencrypted metadata about the device and network that's difficult to secure and can be useful for attackers.
I agree. Supporting proper security and encryption across the whole network stack is really a challenge. And actually, access devices face the same challenge and are no different in this than any other host on the network. But we try to overcome these challenges by implementing IEEE 802.1 AE MACsec standard. As a major feature of our Access OS 11.8 release, we implement this support for both the pre-shared key variant as well as the EAP TLS over 802.1x. While the pre-shared key variant requires pre-configuration, both on the access device and the switch side, I think the real benefit for our customers lies in our unique setup having 802.1x in EAP TLS mode enabled by default. During the 802.1x EAP TLS authentication, MACsec encryption keys are actually negotiated between the access device and the network switch automatically, and therefore they do not require any kind of pre-configuration. And I think this is a real benefit over the pre-shared key variant. But let's step back for a second and get an overview of the MACsec standard and what it brings to the table. So MACsec essentially secures host-to-host links on network layer 2, and this is traditionally being used by switches for securing uplinks. But at Access, we have brought this functionality down now onto our network devices to help securing network traffic between the access device and the switch. And since MACsec operates at layer 2, it secures network protocols that actually do not offer any native security, such as DHCP and NTP. But also it adds an additional layer of security to protocols that are already providing security, such as HTTPS and other TLS-based applications. But in both cases, MACsec secures the link with an 128-bit AES encryption to increase the protection against man-in-the-middle, network sniffing, and replay attacks. So, Ron, how can we utilize this to create more secure networks?
So let's first talk about the networking components of a solution to address this challenge, along with access devices. The first is network switching, which provides both power and network connectivity to access devices. The Aruba switching portfolio uniquely spans from access layer to aggregation to core, even to the data center, and all run a single operating system. And our emphasis in developing this portfolio has been operational simplicity, always on high performance, and enhanced end-to-end security, of which MACsec is a key part. The second component is ClearPass Policy Manager, which is an enterprise-grade network access control solution. You'll also hear it called a NAC. That provides visibility, authentication, authorization, and network enforcement capabilities along with guest services, and also integration with a broad portfolio of third-party solutions. ClearPass also offers onboard and on-guard for device provisioning and posture assessment. Let's take a look at these now to see how they work together with Axis cameras to seamlessly enable MACsec encryption on the network. For this scenario, we're going to be assuming that a customer is installing a new camera. This could be in a retail outlet, healthcare facilities, sporting arena, or in many other common deployment locations. The first thing that happens is the installer, after physically mounting the camera, plugs the camera into any port on the Aruba switch. And I really want to emphasize that last point. We designed the switches to have what we call colorless ports, which means that the network access that the individual switch port has is completely dependent on the type of device that's making the connection. I don't need to have a specific port for cameras, for network printers, or any other devices since they can be dynamically assigned when the device plugs into the switch. With Axis devices, we can even extract the 802.1ar device ID certificate that's securely stored on the camera and validate that the device is indeed an Axis camera and that the serial number of the certificate matches the MAC address the switch sees on the network. And this is an important step to help ensure that the device hasn't been spoofed on the network. You'll see this check happening in the ClearPass screenshot, which helps illustrate what a typical network access control policy looks like in ClearPass. Once the camera is validated, the ClearPass policy assigns a role to the device based on the serial number or MAC address of the device. The role contains all of the instructions for the network access this device needs in a true zero trust fashion. Policies and roles can be created once and then utilized for hundreds or even thousands of switches and access devices deployed across the world. As you can see from the screenshot of ClearPass, this role is used in the policy to assign the right network access for the camera. An important part of this process is that ClearPass knows from the policy definition that MACsec needs to be enabled for this device and is also able to communicate with the switch to negotiate encryption keys and ensure secure communication with the camera. These policies can also be shared with the rest of the infrastructure to set up a zero trust connection back to the resources the camera needs, such as Axis Device Manager, Camera Station, or another VMS. And as Andre discussed previously, MACsec is a layer 2 method of encrypting data in transit, and it's unique in its ability to encrypt low-level protocols such as DNS, ARP, DHCP, and other methods that might not be encrypted by default. One important configuration note is that MACsec secures from host to host only, not end-to-end across several hosts. If an end-to-end MACsec connection is needed, you'll need to set this up between each connecting host along the way, illustrated here, which can also be automated via policies. Andre, what are your thoughts thus far on this capability between Aruba and Axis devices?
To be completely honest with you, Ron, this is very impressive. Thank you for taking us through the setup. I think the last piece we're missing now is looking at the actual end result of having the Aruba switching fabric and the Axis device securing their links across the network. Imagine that someone managed to breach into a network and were to sniff on the traffic to obtain information on the network activity, for instance. In our example here of a non-MACsec protected network, you can see that there are a lot of useful information available for such an attacker. For instance, we can see here that the Axis device is streaming its video and audio data through the RTSP-RTP protocol. But looking at the MACsec protected version of the same network, all an intruder can see is rather useless data that does not provide any insights or attack surface to take advantage of.
I agree. And this is a great illustration and really helps visualize the layer of protection that MACsec provides to all of the data between the device and the switch. My background is mostly with security monitoring solutions, mainly on the SIM, NDR, and DLP side. And one important thing to note for other professionals in these roles is that even though the traffic is encrypted at layer 2 and opaque to unauthorized users, it's still available in its original unencrypted format via the port mirroring capabilities of the Aruba switch. That means that if you have security monitoring tools that depend on DNS, DHCP, ARP, and other protocols being visible and available for security inspection, you still have this ability on a port configurable basis. And yes, even this policy can be centrally defined and pushed to each switch.
Yeah, Ron, I really like the simplicity of the setup as well, utilizing the different IEEE solutions of 802.1x, AR, and AE MACsec for securing data without adding any extra cost or work for customers to set these things up. And the broad availability in Access network products really ensures that we can provide this technology and benefits across many installations for our customers as of today.
Yes, I agree. And one policy to control the entire process has been very valuable for our joint customers and enables them to quickly scale across hundreds or even thousands of sites without the risk of human error. This is a great way to protect data in transit and helps ensure that low level network telemetry isn't visible to unauthorized users. From an attacker's perspective, the ability to inspect things like DNS, ARP, DHCP, and other protocols can give important information about the network's topology, simplifying attacks and reducing the time it takes for lateral movement. Encrypting these data with MACsec is a great high performance way to prevent this from happening.
So that's it for the session. We hope you enjoyed it. If you have any questions or feedback, please contact us on our Access for IT Teams mail address, but also have a look at our joint integration guide for more technical details, as well as the Access for IT Teams page on access.com. Thank you for today, and thank you, Ron, for joining us. It was great having you here.
Thank you, Andre. It's been a pleasure speaking with you today. I can't wait to hear the customer stories of successful deployments and also thwarted attacks from our joint customers that have deployed MACsec.